Good afternoon, everyone. Welcome back. Today we are going to discuss the topic of sets. In the earlier topic of permutation and combinations, we were in the process of collecting things and then we were arranging those things. So we are taking that concept forward with sets. Now, what is a set? A set is defined to be a collection of well-defined distinct objects. Okay, well defined and distinct. So important word here is well defined and distinct. So what does it mean is that when I'm trying to collect things, so I will collect maybe balls. So I'm collecting balls. So maybe I from a huge collection of balls, I take out all red balls. So that is a set of red balls. Then I may take out balls of same size. So some quality is there which is binding all the items in that set together, or which is common to all the objects in that set. Now, how do we represent it? It is represented by a capital letter and the objects are represented by small letters. Okay. And there are two ways in which we can represent the set. One is called as the rooster method and the second is called as the set builder form. So rooster form is in which we are listing out all the possible items or all the possible objects of the set. So in this case, see, when like in this is a form of, just let me change the color. So here we can see that A, I'm writing A. So set is represented by a capital letter. So I'm writing A. Then I will use the curly bracket. Okay, remember in school we used to do a curly bracket. You studied curly bracket, so I will put these curly brackets and I will put all the elements. I will list all the elements. So in this case, what are the elements? 1, 2, 3, 4, and 5. Okay, so these 5 I have listed. So this is called as the rooster form of representing a set. What is the set builder form? When the properties which are satisfied by all the elements of the set are put across, then we call it as the set builder form. Okay. So in this case, see, X is such that X is equal to M being an integer lying in the interval 0 less than M is less than 6. So if this set, okay, if this set A is equal to 1, 2, 3, 4, 5. This is which form? This is the rooster form. If I want to write that in the set builder form, how should I write that? I'm writing this as X. And what is this colon represent? This colon represents such that. Okay. So X. So what is A? A is collection of elements X. How is X? X is equal to M. But what is a property of M? M is going to lie between the interval 0 less than M less than 6. Okay. Can I see here? 1 is greater than 0, right? 1 is greater than 0 and 5 is less than 6. Okay. So this set I can represent it by this method. Okay. So I can write this as equal to X is such that X is equal to M. How is M? M is an integer. M is an integer lying between the interval. Lying between the interval 0 less than M less than 6. Okay, clear? So this is the rooster form and this is the set builder form. I hope you have understood this. Okay. Yes, Pooja, good afternoon. Yes, Srinidhi, Subhashri, Sonali, Rajesh, Mohammed, Saurabh, Lakshita, yes, Ustad, Avdesh, Divya. Okay. Yes, Divya, yes. X is such that X is. 0 and 6 are not involved. Very nice. See, Why are 0 and 6 not involved is because of the sign. If I write 0 less than equal to m less than or equal to 6, then 0 and 6 will also be part of the set. But here I know 0 is also not there, 6 is also not there. So I am using 0 less than m less than 6. When will I use this sign? Less than or equal to? I will use that when the number is also included in the set. Okay. Now, there are some names that you should know. When I write this like this is called as phi. Okay, this is called as phi. How do I write it? I'll draw a circle and put a line across. Phi is called as the null set. It is a set with no elements. Okay, it is a set with no elements. So, is this equal to? If I have a set which contains only the number 0, are they equal? No. Because phi is a set with no elements. There is nothing inside. But in this case, what is happening? I have an element 0. 0 is also an element which is there. And so phi is not equal to 0. How do I represent phi? Phi, I can write it like this, or I can write it like this also. Only the brackets, nothing inside. Okay. Now, equal sets. Then, so we have talked about null set. Now we are going to talk about equal sets. What are equal sets? Two sets A and B are said to be equal if every element of A is present in B and every element of B is present in A. Okay. So if I am talking of students, okay, so students of class 11B, 11A. So if there are 5 students, 1, 2, 3, 4, 5. Okay, these I am writing the roll numbers. Okay, I am writing the roll numbers of students in class 11th A, absent students. So these are 1, 2, 3, 4, 5. What if I write the students who are absent in 11B? Roll numbers of students who are absent in class 11B. Then this is 1, 2, 3, 4, 5. Then what do we say? We say that the set A is equal to B. Why? Because roll numbers this is equal to roll number this, and we are saying these are absent. Okay, we are only talking about the roll numbers, not the students. So here, when every element of A is present in B and every element of B is present in A, we say that the sets are equal. Now, equal and equivalent are different. Okay, so we have talked about equal set. Let us talk about equivalent set. Two finite sets A and B are equivalent when n of A is equal to n of B. If n of A is equal to n of B. Okay, in this same example of absentees, if I'm writing the names of the students, like class 11th A, these 5 students are absent. In class 11B, these 5 students are absent. Then we say that the sets are equivalent. Okay. Then we say that the sets are equivalent because 2 students cannot be the same. So therefore, n of A is equal to n of B. There are 5 students absent in class 11A. There are 5 students absent in class 11B. But are the students same? No, they are different students. So we just say that these sets are equivalent. Then singleton set. A set containing one element is called as a singleton. Single means one. So any set which contains only one element, we say it's a singleton. So like here we have written A is equal to 6. This is a singleton set. B is equal to 5. It will be a singleton set. Okay, I have already told you the importance that phi and the set containing only 0 are not equal, or they are different sets. So phi is not equal to 0. Then we come to the concept of universal set. So what have we talked about? We have talked about equal set when all elements of A are present in B and all elements of B are present in A. We say that the sets are equal. Second, we talk about equivalent set when the number of objects in set A is equal to number of objects in set B. We say these are equivalent set. What is a singleton set? A singleton set is a set which contains only one element. Then what is a universal set? Universal set is a set containing all elements of the question. It is called as a universal set. Okay. So for example, let us see this example. A is equal to 2, 4, 6, 8, 10 and B is equal to 4, 6, 7. Then I'm going to write universal set. It is represented by S or it is also represented by like E, the cursive E. So similar to that, but with a line under like going back. So this. So it is going to contain all elements in the question. So what are the elements? 2, 4, 6, 8, 10. And then we have 4, 6, 7. Can you see that 4 and 6 are present in A also? And 4 and 6 are present in B also. So will I write them 2 times? No, I'm going to write them only 1 time. Whatever numbers are repeated in both the sets, I'm going to write them only 1 time. So let us start from here. 2. Okay, and usually you will write it in the ascending or the descending order. Okay, so this is 2. Then I have 4. Then I have 6. Okay, 2, 4, 6. Then I have 8 here and I have 7 here. So I will write the 7 first. 7, then 8, and then 10. Okay, so this is my universal set for the given question of A and B. Okay. I will not repeat the numbers which are written 2 times. If they are part of 2 different sets, I will not repeat them. Okay. Yes, Divya, that is a null set. Yes, Durgesh, right. Okay. So we have talked about null set, equal set, equivalent set, singleton set, universal set. Okay. Now complement of a set. So what is complement of a set? Complement of a set is it contains all the elements in the universal set which are not part of the given set. Okay. So we have the set A. Okay. What is my set A here? Okay. Here I will write it here. Now A contains 2, 4, 6, 8, 10. And what does my universal contain? 2, 4, 6, 7, 8, 10. So I have A, 2, 4, 6, 8, 10. Okay. What is my universal set? 2, 4, 6, 7, 8, 10. Okay. So let me check. Is 2 present from here? I will check from the universal set to A. Is 2 present? Yes. Is 4 present? Yes. 6 present? Yes. 7? No. So my A complement, which is represented by this, is equal to 7. Then let me check. 8? Yes, it is present. And 10? It is present. So my A complement will be only containing the element 7. And what is this set? This is a singleton set. Okay. So that is known as complement of a set. For a set A complement is a set containing all elements present in the universal set S, but not in A. Okay. Then A minus B. A minus B is a set which contain all elements of A which are not present in B. Okay, so let us see. I already have A. Let me write down B. Okay, what is B? B contains 4, 6, 7. Okay, the B contains 4, 6, 7. What is A containing? 2, 4, 6, 8, 10. Okay, so A minus B. I have to check elements of A. If they are present in B, I will not write. If there are elements in A which are not present in B, I am going to write them. So 2. Is 2 present? No. So I write down 2. 4. 4 is present here also. So I will not write down. 6. Again, this is present. Then 8. Is 8 present? No. And then 10. Okay. So I'm going to start from A to B. Okay. Now you can see that 7 is present over here. I'm not writing that in A minus B. Why? Because I'm only writing elements which are present in A but not in B. Okay. So this is A minus B. So A minus B is 2, 8, 10. Always remember that A minus B is always a subset of A. Why? Because it is containing elements which are part of A but not present in B. Okay. Now let us see B minus A. Okay. Let us see B minus A. Let us check. What is the first element of B? B is 4. Is it present in A? Yes, it is present in A. Okay. 4 is present in B and 4 is present in A. 6 is present in B. 6 is present in A. 7. Is it present in A? No. Okay. So only 7. So B minus A is a singleton set 7. Okay. So as you can see that A minus B here is not equal to B minus A. Okay. That in this question we have, I can see A minus B as a set containing elements 2, 8 and 10. Whereas B minus A is only 10, only 7. And so we can safely say that A minus B is not equal to B minus A in this question. Again, remember, B minus A is always a subset of not A or a set of B, not A. Okay, just make this correction. Okay, B minus A. So always remember, this is a good theory question. A minus B is a subset of A, whereas B minus A is a subset of B. Okay, is a subset of B. Then we come to the concept of cardinal number. The number of elements in a given finite set A is the cardinal number. So finite set, okay. So number that which are countably finite. So we say that whatever number of elements are there, that is called as the cardinal number. Like in this case, I have A minus B to be equal to 2, 8, 10. Okay, how many elements are there? 1, 2 and 3. So how will I write down? N of A minus B, that is cardinal number of A minus B is 3. 1, 2 and 3. So 3. Okay. Clear up till now? Just let me know if you've understood. Saurabh, you want equivalent set? Okay. Yes. Mato, you have to color the circle in your exam paper. It's an MCQ question, so you can use any pen for your rough work. But over there, whatever the instructions are there, you have to follow. Okay, when you fill the forms, you will come to know. Yes, Dubya, very good. You understood? Yes. Bibu? Yes, very good. Okay. So we have talked about cardinal number also. Okay. Equivalent number. Two finite sets A and B are equivalent when n of A is equal to n of B. Right now we found out this cardinal number. Then we say n of. Now I will show you here. What are the elements of A minus B? 2, 8, 10. What are the elements of B? B is 4, 6, 7. Okay. We know in the given question it is B is given to me as 4, 6, 7. Now what is n of B? What is n of B? How many elements are there? 1, 2, 3. So it is 3. Okay. Here you see A minus B. N of A minus B is 3. N of B is also 3. We say these sets are equivalent. Why are they equivalent? That the number of elements in this set, first set is equal to number of elements is second set. So we say that when their number matches, we say they are equivalent set. Okay. Is it clear now? Okay. Two finite sets are equivalent when n of A is equal to n of B. So here we have taken that example and showed that n of A minus B is 3, n of B is 3. Then these sets, A minus B and B are equivalent sets. Okay, now let's see. So what is the symbol? Does it represent? If something is like this is given to me, curly bracket A and B, it means what? It is a set of. Okay, is a set of. Then in this one, like I will show you, where is it? Okay, in this set builder method, we are using these different types of symbol. Okay, can you see this? We are using this different type of symbols. So therefore, we can even have this. We can even have this belonging to. Element belongs to set. Okay, so I may have, like for example, I may have A is equal to X is equal to 2M, where M belongs to I. Means what? This means belongs to. Belongs to. I is what? I is integer, set of all integers. So M belongs to I. So whenever I have this kind of symbol is because I want to specify what M is about. Okay. So the element belongs to the set. Okay. Then when I use this, A is a proper subset of B, and when I use this symbol, so this means proper and line means is a subset of. Okay, so proper subset and just subset. These are two concepts. Then for union, I'm going to use this. So if I have writing A union B, it means I'm going to take all elements of A and I'm going to take all elements of B and write them down. Okay, A union B means I'm going to take all elements of A and all elements of B and write down. What does A intersection B mean? This means intersection means I'm going to take elements which are common to both the sets A and B. Okay, so I hope you've understood the symbols. Curly brackets, elements written in small case means it is a set of. This E type of symbol means elements belongs to a set. This means like a side U means A is a proper subset of B, and side U with a dash underneath is A is a subset of B. Upside U means it's a symbol of union, and downwards U means it's a symbol of intersection. Okay. Now let us talk about what is a subset. Okay. Here we have just discussed the symbols. Let us go in detail. So if every element of set of A is also present in Q, then we say that P is a subset of Q. If every element of set P is also present in Q, we say, okay. So here, let us take this example. P, I use 1, 2, and Q is 1, 2, 3, 4. Okay, I have two sets, P and Q. Now 1 and 2. Is 1 present in Q? Yes. If 2 is 2 present in Q? Yes. So then I say that P is a subset of Q. Okay. And if there is at least one element in Q which is not present in P, if there is at least one element in Q which is not present in P, then we say that P is a proper subset of Q. Okay. Then we say P is a proper subset of Q. In this case, is P a proper subset of Q? Yes. Why? Because P has the elements 1 and 2 and Q has 1, 2, 3, 4. So 3 and 4 are present in Q but which are not present in P, and so we say that P is a proper subset of Q. Okay. So what is a subset? If every element of set A is also present in set Q. Now, important. If a set has n elements, then it has 2 raised to n subset. Okay, this is very important. This you use for sums also. So suppose I have A to be equal to 1, 2, 3. So what is the cardinal number of A? Cardinal number of A is 3. Okay, 1, 2 and 3. So cardinal number of A is 3. Then it says how many subsets are there? Number of subsets is equal to 2 raised to n. What is this n? N is this cardinal number. Okay, this cardinal. So in this case, 2 raised to 3, which is equal to 8. So let us now write down the subsets of A. Okay, I have the set A. A is 1, 2, 3. So subsets. Okay. I'll just tell you a small thing that you need to remember is that null will also be a subset of A. Okay, null will be a subset of A. So this is one subset. Then 1, 2, 3, the set itself is a subset of itself. Okay, so 1, 2, 3. These two are always there. Okay, the null set and the set itself, they will be part of the number of subsets. Okay, so this we are talking about all the subsets. So this is first subset, second subset. Now first we will write down the single numbers. Okay, single numbers will also form a subset. So what is the single number? 1, single number 2, single number 3. Okay, then I will form groups. These are all single number, then 1, 2 and then 1, 3. 1, 2 and 1, 3. Okay, then I have what is remaining? 2, 3. Okay, 2, 3. Okay, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8. How many subsets do I have? I have 8. Okay, so I have a set. I will write down all the subsets. While writing all the subsets, remember that null is a subset. The set itself is a subset of itself. So these two are there, and all the other elements I'm going to write down in permutation and combination. So I have single numbers, then I have double numbers. Okay, all those things I have written as subset. Now this is a subset. How many proper subsets are there? If I remove the same set from the list of subset, I have proper subset. Okay, because what is proper subset? That there is at least one element in the set which is not part of the subset. Okay, so 2 raised to 3 is the subset. 2 raised to n minus 1 is the number of proper subset. So proper subset in this case will be equal to the null set, then 1, then 2, then 3, then 1, 2, then 1, 3, and 2, 3. This is 1, 2, 3, 4, 5, 6, 7. So how much is this? There are 7. So 2 raised to, this is 2 raised to n minus 1. So 2 raised to 3 minus 1, which is equal to 8 minus 1, which is equal to 7. Okay, so we are talking of subsets. So when do we say the set is a proper subset? Is that when there is at least one element in the set which is not present in the subset, then we say it is a proper subset. Then we have how many subsets are there? 2 raised to n subsets are there. How many proper subsets are there? 2 raised to n minus 1 proper subsets are there. Okay. Then we have the operations, intersection. Then we have union. Then we have A minus B, B minus A. Then we have A triangle B, that is the binary function, binary operation on the sets. Okay, so we are going to discuss them one by one. Clear up till now? Ramanatheshwari, these 4 chapters, the weightage is 30 to 50%. Okay. Shubhashri, I don't have the answer for that question. You have to check the website. Okay, Vishnu, cardinal number. Okay, suppose I have P containing the element 4, 5, 9, 11. Okay, how many elements are there? 1, 2, 3, and 4. 4 elements are there. Then I say cardinal number, so n of P. This is how I represent it to be 4. Okay, 1, 2, 3, 4. That is the cardinal number. Is that clear? Just have to count the number of elements in the set, and that is your cardinal number. Srinidhi, where n is 3? When the number of elements are 3, we say n is 3. Okay, here a minus b, you had 1, 2, 3 elements, so you said n is 3. Here we have 4, so we are writing n is 4. Okay. Yes, but when we are doing sums, you will understand b minus a again. Okay. Yes. A minus b, b minus a. When we will do the sums now, it will become easier for you to understand. Okay. Yeah. Good. The others have understood. Very good. So the collection of all possible subsets of a given set is called as the power set of A, and it is denoted by P of A. So whatever we have done now, we will write them as power set of A. Okay. The collection of all possible subsets of A. A set containing n elements will have 2 raised to n subsets. A set containing n elements will have 2 raised to n minus 1 proper subsets. Okay. So in the example we have taken that if A is equal to 1, 2, 3, okay, then we say power set of A is equal to all possible subsets of A. So that is the first is the null set. Then the set itself 1, 2, 3. Then 1, then 2, then 3, then 1, 2, then 1, 3, and then 2, 3. Okay. So my A is 1, 2, 3. So what is my n? N of A is 3. 1, 2, 3. So n of A is 3. How many subsets will I have? 2 raised to n. 2 raised to n is equal to 2 raised to 3, which is equal to 8. Let us check whether we have got 8 subsets. This is 1, 2, 3, 4. Okay, let me even do color it. Okay. So this is the first subset. This is the second subset. Third, fourth, fifth, sixth, seventh, and eighth. Okay. So power set of A is this much. Okay. It was going to contain 8 subsets. Now, how many proper subsets will be there? 2 raised to n minus 1. So 2 raised to n minus 1 is how much? 8 minus 1. So I'm going to have 7. Let us write down the proper subset. Okay. Proper subsets. Okay. This will be equal to what? First is the null set. Then we will have 1, 2, 3, 1, 2, 1, 3, and 2, 3. So this is 1, 2, 3, 4, 5, 6, 7. Okay. I hope now this is clear, Srinadev. As we do more and more sums, the concepts will be more clear. Okay, so now let us move to the operations. Okay. Now what is an operation here on the set? First operation is intersection of sets. If we have two sets A and B, then intersection of these two sets is written as A, symbol this intersection B, and this set contains all elements common to both. All elements common to both. Okay, this is very important. So you should not get confused. So it is common to both. Now here we have taken an example. A is given to me as 2, 4, 6, 8, 10 and B is given to me as 4, 6, 7. Okay. So A intersection C. I will check. Okay. Is 2 present here? Is 2 present here? No. So I will say no. 4. Is it present in both the sets? Yes. I'm going to write down 4. 6. Is it present in both the sets? Yes. 6. Then 8. Is it present in both the sets? No. 10. Is it present in both the sets A and B? No. Let me check B. 4. Yes, it is present. So I've already written. 6. It is already present in A also. So I've written there. 7. It is not present. Okay. So whatever common out we have, that is intersection. Okay. All elements of A which are present in B also are written as A intersection B. So common things, okay, are written as A intersection B. Okay, here we are talking of B. Okay, let us see A intersection C. Let us do another one. Let us see A intersection C. Now A is given to me as 2, 4, 6, 8, 10 and C is given to me as 5, 7, 9. So A intersection C. 2 is present here. Is it present here? No, I can't use it. I can't use it. 4, is it present? No. 6, no. 8, no. 10, no. Is 5 present in A? No. 7 present in A? No. 9 present in A? No. So what is A intersection C? It is the null set. Okay, it is the null set. So I have A intersection B as 4, 6, A intersection C as a null set because there is no common elements between A and C. Okay, this is known as intersection. Okay, so I will write it as A and intersection means I'm going to write down U in the reverse way. Okay, ulta U. So A intersection B. Then we have concept of A union B. I have the concept of A union B. A union B means take everybody along. Take all elements of A, take all elements of B and write them all together. But in this case, remember, you are not going to you are not going to repeat the numbers. Okay. So if there is an element in A also and B also, you're going to write it only once. So in this case, I have 2, 4, 6, 8, 10. So first I'm going to start writing elements of A. So 2. Okay. Then 4. Okay. So 4 is present here also and here also. In A also and B also. 6. Is it present here also? Yes, I'm going to write it down once. Then I have 8 over here, but I have 7 here. So I'm going to write down 7 first. So 7, then 8, and then 10. Okay, so 2, 4, 6, 7, 8, 10. So this is union 2, 4, 6, 8, 10 and there is also 7 which is also not written yet. So I'm going to write down that also. So 2, 4, 6, 7, 8, 10. So there it contains A union B contains all elements of A and all elements of B. We will write common elements only once. Okay. So first we talked about intersection. Second we are talking of union. How do I write intersection? A intersection B. This is intersection. And if I write like this, it means union. Okay, it is union. Is that clear? Then the third operation we are going to talk about is symmetric difference. The third operation we are going to talk about is symmetric difference. Please make this correction. This is not this, this is minus. A symmetric B is A union B minus A intersection B. Okay. This becomes easier for you to understand. So, Saurabh, I hope you have solved your query. Yes, Bihu. Just let me see, Saurabh. Yes, Saurabh, I explained equivalent sets, right? Yes, union means all numbers and intersection means which are common to both. Yes, Khushdeep, yes, very good. That if there are no common elements, then we say the intersection is null set. Okay. Yes. Yes, Pratidnya, good. Okay. Now we are going to talk about symmetric difference. So if I have two sets, A and B, then the elements which are present in exactly one set, we are going to write down. So all the elements which are present in A but not in B, and all the elements which are present in B and not in A, we are going to write them down. Okay, so let us take this example. A is 2, 4, 6, 8, 10 and B is 4, 6, 7. Now I know A intersection B. I can find out A intersection B is the common elements. Common elements are 4 and 6. So this is 4 and 6. Okay. Now what is union? Union means I'm going to write them all together. So I'm going to write them as 2, 4, 6, 7, 8, and 10. Okay. This is A union B and this is A intersection B. Now what does symmetric difference say is that I'm going to write down only those elements which are present either in A or in B. Okay. So this is A is given by which are the elements which are present. So you can write this as A minus A union B minus A intersection B. Is 2 present here? No. So I'm going to write down 2. Okay. Is 4 present in both? So no, I'm not going to write down 4. Is 6 present here also? No, I will not write down here. And so I have what? 7. Is it present over here? No. 8? No. And 10? No. So I will write them as this. 2, 7, 8, 10. Elements which are present in either of the set or only exactly one set. Okay. And which are not common to both the set. So I have A triangle B to be 2, 7, 8, 10. Now we have what is known as Cartesian product of sets. So I have two non-empty sets A and B. Then what I do is I take all the elements of A and I take all the elements of B and write them as pairs. Okay, I take all the elements of A and I take all the elements of B and write them in pairs in such a way that always the first element will belong to one set and the second element will belong to another set. Okay. In Cartesian product of sets, I take two sets, A and B. I take one element from set A and I take one element from set B and form their pairs. the pairs are ordered pairs. Okay, the pairs are ordered pairs in such a way that the first element will always belong to one set, and the second element of the pair will always belong to the other set. Okay, so here. Okay, so here you can also see that this is an example of the set builder form. A cross B is such that A cross B elements A and B, small ab of the set A cross B are such that A belongs to A, small a belongs to A, and small b belongs to the set B. What does this mean? Mean that A cross B is the Cartesian product of set such that element A belongs to capital set A, element B belongs to the capital set B, and we are going to always write it in that order. If A is 5, that is A is a null set and B is also a null set, then A cross B will be a null set. Okay, so this is an important theory question. If A is a null set, B is a null set, we define A cross B as null. Okay. Now we are taking the example A to be equal to, written it down. Yeah, okay. Let us see. Now I have A. Okay, so I'm going to write down A cross B. How do I write down A cross B? Here I have been given A and I have been given B. So A cross B, what will I write? I will put a small bracket, okay, round bracket. What will I write? First element will be from A and second element will be from B. So 1, 4, okay. Then 1, 5, okay. First element from A, second element from B. Then I will take the second element of A, 2, 4 and 2, 5. Then 3, 4, because I am taking the next element, 3, 4 and then 3, 5. Okay, so this is A cross B. Is it equal to B cross A? Let us find out. So I will write down B cross A. Let us see. First element will belong to B. Here what happened? I had written A first, so the first element was always from A. Now I am writing B first, the first element will be from B. So what is the first element of B? 4. What is the first element of A? 1. 4, 1. Then 4, 2. Then 4, 3. Then 5, 1. 5, 2. And 5, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, can you see, is A cross B equal to B cross A? Are they the same? Can you tell me, are they the same? Yes, give me answers. Are they the same? Yes, very good. They are not same. Okay, they are not same. Why? Because here the first element is what? 1, 4. Okay, here what is happening? The first element is what? This is 1, 4, 1, 5. This is 4, 1, 5, 1. Okay, so they are not same because what happens in an ordered pair? In an ordered pair, the order is important. Okay, in an ordered pair, the order is important. In this case, what is happening in A cross B? How do I write the ordered pair? In A cross B, in the ordered pair, first element belongs to A. First element belongs to A. Second element belongs to B. Okay. Okay. In A cross B, first element belongs to A and second element belongs to B. So I have 1 belonging to A, 4 belonging to B. Then 1, 5, 1 belonging to A, 5 belonging to B. Okay, so this is what is a ordered pair. Khushdeep, I hope you've understood that ordered pair means what? The order inside the pair is important. You can't change that. Okay, so that is important. What will happen in B cross A? In B cross A, first element will belong to B and second element will belong to A. Okay. So this is the difference. Hope you've understood. Just put in whether you've understood or not. Cartesian product of sets. Very good, Lakshita. Very good. Yes, Akaldeep. Answer is correct. Rohini, answer is correct. Pratidnya, the PPT is already uploaded. Okay, so PDF you can see from there. Yes, very good, Divya. Lalit. Barkatullah. Yes. Okay, excellent, excellent. Good progress, good things. Now let us go to De Morgan's laws. Okay, so we will just revise up till here. So what is a set? Set is a collection of well-defined distinct objects. We can represent it by in the rooster form or the set builder form. What is a rooster form? When I list down all the elements of the set. This is useful when I have very limited set. So okay, if I have 5 to 8 or even 10 elements, I will write them down. But what if I have 20, 25? So it will become very difficult for me to write down all the elements. And there is a chance that I may mistakenly, I can make a mistake while writing also. Instead of 36, I may write 39. So we don't want that. So in that case, when the number of elements are large, I will represent the set using the set builder form. Okay. When the number of elements is small, I can easily use the rooster form. But when the number of elements is large, then I will use the set builder form. Set builder form highlights the property that is binding all the elements of the group together. Okay, then we have the concept of null set. Null set is a set which contains no element. Equal set when all the elements of A are present in B and all the elements of B are present in A, we say they are equal sets. What is equivalent set? Equivalent set means that two sets are equivalent when the cardinal numbers are same. What is a singleton set? Singleton set is a set which contains only one element. What is a universal set? It is a set of all the elements contained in all the sets in the given question. What is complement of the set? Complement of the set is the set of all the elements in the universal set which do not belong to the given set. Okay, all the elements in the universal set which do not belong to the given set. It is represented by A dash. Okay, the dash sign. A minus B is the set of all the elements in A which are not present in B. A minus B is the set of all the elements which are in A and which are not in B. Okay. Okay. Cardinal number is number of elements in a given set. What is power set? Power set is the collection of all possible subsets of a given set A. And how many subsets can a set have? It is equal to 2 raised to n. How many proper subsets it can have? 2 raised to n minus 1. Okay. So these are very good theory questions also. Okay. Then ordered pair. Two elements A and B listed in a specific order form the ordered pair A and B. Okay, here, so the first element A will belong to set A and the second element B will belong to set B. These are the symbols, proper subset, just subset, A union B and A intersection B. So we are talking about subsets, proper subsets, and we are now talking about operations. In intersection, what do? We take out all the elements that are common to both the set. So that is intersection. What is in union? Union means taking all the sets of given two sets A and B. We write them together. Then that is A union B. Then we talked about symmetric difference. Symmetric difference is that we take the collection of elements from both the sets which are present only in one set. Okay, that simply means we are not going to take up common elements. Okay, we will remove common elements from the union of sets, and that will give me my symmetric difference. Then we talked about Cartesian products. So what does Cartesian product say? If A and B are two non-empty sets, then the set of all ordered pairs A and B such that A belongs to A and B belongs to B is called as the Cartesian product. Is called as the Cartesian products of A and B and is denoted by A cross B. Okay. So for this, you must have two non-empty sets, then set of all ordered pairs. So the important word here is ordered pair. And what is ordered pair? Where the order in the pair is important. Okay, so ordered pair, where the order is very important. Two elements A and B listed in a specific order form an ordered pair. Okay. So in this case, what will be the ordered pair? It will be that small a belongs to set A, capital A, and small b belongs to set B. Okay, so I will write this as A cross B is equal to AB are such that A belongs to A and B belongs to B. Okay, so we say, and important thing is if A is a null set, B is a null set, we define A cross B as a null set. So that is why here it is very importantly we are talking about two non-empty sets. We don't want this. We want to calculate A cross B, and when can we calculate A cross B is when we have two non-empty sets. Okay. Now you may even have this thing. Sometimes they will give you the set. Okay, so here, see what have they given. So either you will be given two sets A and B and asked to find out A cross B, or you can see this question. Okay, see this question. A cross B is given. You have to find the sets A and B. Okay, A cross B is given. You are supposed to find the sets A and B. So, A now let us see. First element is what? 1 and 4. So I will write 1 here and I will write 4 here. Then this is 1 and 5. Shall I write 1 again? No, I have already written 1. So I won't need to write. Then what will I write? 5. 5 is in which set? 5 is in set B. Then 2, 4. So 2 I'm going to write in the A because first element is going to belong to A, second element is going to belong to B. 4, I already have 4, so I will not write. 2, 5, I already have 2 here and I have already written 5 here. 3, 4, so 3 I'm going to write here, 4 I have already here, and 3, 5. 3 is written here, 5 is written here. So I can write this. So first example, two sets are given A and B. You are asked to find out A cross B. In the other type of questions, you will be given A cross B and asked to find out the set. So A cross B is given and you are able to find out the two sets. Let us take another example. Here they've already given you A cross B, 3, 2, 3, 4, 5, 2, 5, 4. Let us see. So here A and here B. Now 3 and 2. 3 will belong to which set? A. 2 is going to belong to which set? B. So this is 3. This is 2. Okay. Then 3, 4. 3 already written here. I will not write it again, but 4 I'm going to write it here. Why? Because it is the second element in the pair. Second element in the pair will belong to B. Then 5, 2. So I'm going to write 5 here. 2 I've already written. Then 5, 4. 5 I've already written here. 4 I've already written here. So this is these are the two sets. A is 3, 5 and B is 2, 4. Okay. So given sets, you can find A cross B, or A cross B is given, you can find the given sets A and B. Okay. So we have A to be 3, 5 and B to be 2, 4. Is that clear? Yes, very good, very good. Yes, Bhargavi, which example do you want? For which? Okay, Naren, when one set is empty, other is not empty, will we have a Cartesian set? No, because there is nothing in the other set. So I can't have a Cartesian product. Okay, that is why in the definition itself, we are talking of two non-empty sets. Okay. Okay, Naren? Yes, very good, Kushdeep. Divya. Yes, Rohini. Thank you. Yes, very good. Okay. So let us take a break of 5 minutes here. Yes, tech support. Yes, just a break of 5 minutes. Thank you. Yes. Welcome back. Okay. So now we have to understand the De Morgan's law. Okay. We have talked about intersection. We have talked about union. Okay. So now we will try to see what is the relation between union and intersection of two sets. So what De Morgan's law says that if I have P union Q and I have complement of that, so okay, I find out P union Q, then I find its complement, that is all elements other than those present in P union Q. Okay, so this is equal to P dash intersection Q dash. Okay, P union Q dash is equal to P dash intersection Q. So here you can see the symbol is union, and here you can see the symbol is for intersection. Same thing applies for the other way around. If I have P intersection Q, and then if I find its complement, this is equal to P dash union Q dash. Okay, P dash union Q dash. So these are the two laws of De Morgan. So let us solve some sums and then we will be able to find out. So let me write it over here. What do the laws say? If I have P union Q dash, this is equal to P dash intersection Q dash. And if I have P intersection Q dash, this is equal to P dash union Q dash. Okay, let us try and see whether this holds. Okay. Now I have been given a universal set S. S is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So these 10 elements are there. Set P is given to me as 0, 2, 4, 6, 8. And Q is given to me as 1, 2, 3, 4, 5. Now first step, let us find out P dash and Q dash. What is P dash? P dash is all the elements in the universal set which are not present in P. Okay. Now 0 is present in P. 1, I will write it here. 2, already present. 3, not present. 4, present. 5, not present. 6, present. Then 7, 8 is present, and then 9. So I have P dash to be equal to 1, 3, 5, 7, 9. Similarly, I will calculate Q dash. Q dash is all the elements in set S other than these elements. So 1, 2, 3, 4, 5. Okay. So let me just remove those. All the remaining elements of set S which are not present in Q will be Q dash. So this is 0, 6, 7, 8, 9. Okay. I have P dash, I have Q dash. Now let us find out P union Q. What is P union Q? All the elements of P and all the elements of Q, I write them together, and common elements, I will write them only once. Okay. So 0, this is 0, then this is 1, then 2, 3, 4, 5, 6, and 8. Okay. 0, 1, 2 is common, I will write them 1, then 3, 4, 5, 6, and 8. Okay. Because 2 and 4 are common, I will write them only once. So I have got P union Q. Then I will find out P union Q dash. Okay. I will try to find out P union Q dash. So what is P union Q dash? Is all the elements in the universal set other than those belonging to P union Q. What is P union Q? I will cut them here. So this is 0, 1, 2, 3, 4, 5, 6, and 8. So what is P union Q dash? What are the elements remaining? So this is 7 and 9. So all the elements other than those belonging to the set P union Q are 7 and 9. All others belong to the set P union Q. Now let us see P intersection Q. Okay, P intersection. What is intersection? Intersection means those elements which belong to both the sets. Okay, intersection means those elements which belong to both the sets. Which are the elements which are belonging to P as well as Q? This 2 and this 4. These are the two elements which belong to both the sets. So P intersection Q is 2 and 4. Can you see that these are the only two elements which are common to both the sets? So P, which is found in P also and Q also. Okay, now let us see P intersection Q dash. Okay, this is P intersection Q. I will see this. Now, whatever elements are here, I will remove from the universal set. Okay, when I want to find dash or when I want to find the complement, I will use only the universal set. Okay, so 2 and 4. So I will cut down 2, I will cut off 4. What will remain in P intersection Q dash? Those will be 0, 1, 3, 5, 6, 7, 8, 9. Okay. So 0, 1, 3, 5, 6, 7, 8, 9. Okay. So now I have got P dash, I have got Q dash, I have P union Q, I have P union Q dash, I have P intersection Q, I have P intersection Q dash. Okay, I have all this. Now I want to, for here, I will find out P dash union Q dash. Okay, for this I will find out P dash union Q dash. So what is P dash union Q dash? I will take all the elements of P dash and I will take all the elements of Q dash and I will write them together. So this is 0, 1, 5, 6, 7, 8 and 9. Okay, 0, 1, 5, 6, 7, 8, 9. And I will write out P dash intersection Q dash. P dash intersection Q dash. So how much is this? P dash intersection Q dash. What are the elements that are present in P dash and Q dash? 0, no. 3, no. 5, no. So 7, yes. 7 is present in both and 9 is present in both. So P dash intersection Q dash will be 7 and 9. Okay. Now, can you see over here? What does the first De Morgan law says? P union Q dash, P union Q dash is equal to P dash intersection Q dash. Let us see P union Q dash. P union Q dash is here. And what is P dash intersection Q dash? P dash intersection Q dash. Right? Aren't they the same? Yes. Isn't this equal to P dash intersection Q dash? Yes. So first law, first De Morgan's law, I can see that P union Q dash is equal to P dash intersection Q dash. Let us see P intersection Q dash. P intersection Q dash is this. Let me take the black ink. Okay, P intersection Q dash. How much is this? This is P intersection Q dash. P intersection Q dash is 0, 1, 3, 5, 6, 7, 8, 9. This is equal to P dash union Q dash. So what is P dash union Q dash over here? Okay, so this is equal to P dash intersection union, sorry, P dash union P dash union Q dash. Okay. Please let me know whether you've understood or I will repeat. Devansh, what is A intersection A dash? It is the null set. Yes, Lalit. Thank you. Thank you. Yeah, I've written the 3. Yes, Divya, what do you mean P dash is not there? Yes. Okay. Yes. Thank you, Lakshita, Jia, Bhargavi, Subhashri, Pratidnya, Liza, Zeba, Ramanatheshwari. Yeah, very good. Okay. Yes, you've understood? Okay. So let us redo this sum. So for those who have not understood, I will show it again. P union Q. What is P union Q here? P union Q means all sets of elements of P and all elements of set Q. So this is 0, 1, 2, 3, 4, 5, 6, and 8. Okay. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 8. How much is P intersection Q? What are the common elements? 2 is common and 4 is common. So this is 2 and 4. Okay. So how much will be if this is this? Let me change the color. So what will be P union Q dash? What are the elements which are not in P union Q but which are present in the universal set? So let me do this. So 0 is there, 1 is there, 2 is there, 3 is there, 4, 5, 6, and 8. So P union Q dash, what is remaining is 7 and 9. Okay. P union Q and P union Q dash. Okay. Now let us see P intersection Q. So I want to find out P intersection Q dash. Okay, I will find out P intersection Q dash. So what are the elements in the universal set which are not present in P intersection Q? What are those? If I remove this, this is equal to 0, 1, 3, 5, 6, 7, 8, and 9. Okay, this is P intersection Q dash. Okay, so I have P union Q dash and P intersection Q dash. So what does the De Morgan law say? P union Q dash is equal to P dash intersection Q dash, and P intersection Q dash is equal to P dash union Q dash. Okay, so I have found both the left hand sides. I have found the left hand side of P union Q dash. This is P union Q dash is 7, 9. P intersection Q dash is this 0, 1, 3, 5, 6, 7, 8, 9. Now let me go to the right hand side. What is the right hand saying? I must find out P dash. I must find out Q dash. I must find out the union, and I must find out the intersection. Okay, so let us go to that end. Okay, so first step here will be P dash. I have P, so what will be P dash? All elements in the universal set which are not present in P. Okay, so I'll just remove this 2, 0, 2, 4, 6, and 8. So P dash is how much? 1, 3, 5, 7, and 9. Okay. Then let us see what is Q dash. All elements in the universal set which are not present in the set Q. So this is 1, 2, 3, 4, and 5. So what do I have here? 0, 6, 7, 8, and 9. Okay. Now I have got Q dash, I have got P dash. I have to find their union. I have to find their intersection. So P dash intersection Q. What are the common elements? 0, 1, 3, no, 6, no, 5, no, yes. 7 is here, 7 is here also. 9 is here, 9 is here also. Okay. So I have P dash intersection Q dash to be equal to 7 and 9. P dash intersection Q dash to be 7 and 9. Now let us see P dash union Q dash. Means what? All the elements of P dash and all the elements of Q dash. So this is equal to 0, 1, 3, 5, 6, 7, 8, and 9. Okay. Okay, so I have now found out the right hand side. Right hand side was P dash intersection Q dash and P dash union Q dash. Okay, and this I will copy from here. Okay, P union Q dash is 7 and 9. P union Q dash is 7, 9. And P dash intersection Q dash, P intersection Q dash is 0, 1, 3, 5, 6, 7, 8, 9. Zero, 1, 3, 5, 6, 7, 8, 9. Okay. Isn't this equal to this? And isn't this equal to this? Yes. So that is what our De Morgan law says, that P union Q dash is equal to P dash intersection Q dash, and P intersection Q dash is equal to P dash union Q dash. Is that clear? P union Q dash is equal to P dash intersection Q dash. P intersection Q dash is equal to P dash union Q dash. Okay. Right. So I have explained the sum twice. Hope everybody is understood. Yes, Isha. Good. Yes, Devansh. Yes, Divya. Okay. So these are the concepts. And then this another concept which is important while we are solving sums, and especially when we are using Venn diagrams, we are using this formula. Okay. So n of A union B is equal to n of A plus n of B minus n of A intersection B. Okay. Now let me show you this. So I have a set A and I have a set B. Okay. I can have this condition. I can have this condition. I can have this condition. Okay. For example, if I have A is a set of apples and B is the set of oranges, are there any apples which are oranges? Or are there any oranges which are apples? No. So then we say then that these are disjoint sets. Okay, and we represent it like this. When I'm drawing these are called as Venn diagrams. Okay, so A and B are separately written. Okay, now if I say that A is a set of students of class 11 and B is a set of students of the college. A is a set of class 11 and B is a set of all students in the college. Then what we say is that A is a subset of B, because all students who are students of class 11 will also be the students of the college. Okay, same college. So then you say that A is a subset of B. What does this mean? That there is something common between A and B. Suppose I am a maths teacher and I am also a physics teacher. Or let us take our example. So I also teach accounts and I also teach income tax. So then what will happen is, then I say that there are certain teachers which teach accounts as well as income tax. So we have this type of Venn diagram where there is some overlap. So a teacher may teach accounts also and income tax also. What happens here is, let me show this in a bigger diagram. Okay, this is one information. This is another information. And this is the third information. Just understand this. This is the set A and this is the set B. Okay, this is set A and this is set B. Okay, if A is a set, if A is a set of teachers that teach accounts and B is the set of teachers that teach business studies. Okay. Now what does this red line mean? It means, all the red line means these are teachers that teach only accounts. Okay, all the one in red. Okay, all the one in red means that they teach only accounts. What do the green one mean? This means that teachers teach both accounts or business studies. Okay, they can teach any of the subject. Okay, they can teach accounts as well as business studies. What does the yellow one mean? The yellow one means teaches only business studies. Okay, is that clear? Just have this clear in the picture. What does this mean? When I want to find out only something, I will use either the red one or the yellow one. When I want to select or, that is A or B, then I will select what is in between, that is the green one. Okay, and when I want to see what are the number of teachers or who are the teachers, I will select all, red as well as green as well as yellow. Okay, so that is A union B. So red, green, yellow together will be A union B. That will give me all the teachers present in the college. When I am talking of the red region, it means these are the teachers who will teach only accounts. When I talk about yellow, it means the teachers who will teach only business study. and green are the teachers who can teach either business studies as well as accounts. Okay. And what are disjoint set? When there is nothing common in it, when we say it's a disjoint set. Okay, so if I have a sack of potatoes and if I have a sack of apples, can I say that there are some potatoes who are apples? No, that is not possible. Then we say these are disjoint sets. Okay. Here, if I say A is a sack of apple and B is a sack of fruits, then I say that apple being a fruit, therefore the set A is a subset of B. Okay. So the rule says that, what is the formula? N of A union B is equal to N of A plus N of B minus N of A intersection B. N of A intersection B. Okay, so this green one represents the intersection, but for disjoint set, A intersection B is equal to a null set. Therefore, N of A union B is equal to N of A plus N of B. Okay. This chapter is important not only because it is there in set, but it is there also in probability. Okay, so you need to know right now. Okay, so please pay attention. Once you've understood this concept, you will be able to do it there. Okay. So formula is N of A union B is equal to N of A plus N of B minus N of A intersection B. But for disjoint set, A intersection B is null set. So N of A union B is N of A plus N of B. You can even have it for 3 set. So for the 3 set, the formula is like this. So N of P union Q union R is equal to N of P plus N of Q plus N of R minus, okay, sign is very important for 3 sets here, is N of P intersection Q minus N of P intersection R minus of N of Q intersection R plus, this is very important, this plus N of P intersection Q intersection. Okay, so P intersection Q intersection R. So these are the two formula, one when I have 2 sets and the second when I have 3 sets. How will this 3 set look like? Okay, it looks like this, P, Q, R. Okay, so this is P, Q, and R. Okay, this portion here is N of is P intersection Q intersection R. Okay, this portion, will color this. Okay. The area which is common to all the sets. This is P, this is Q, and this is R, which is all the set is P intersection Q intersection R. If I want to find out this thing, this is what? P intersection R. What is this? P intersection R. So this is the way you have to find out. Okay. Now let us go to the sums. The more sums we do, the more clearer the concept will become. No, this type of diagrams are known as Venn diagram. Okay, Kushdeep? Yes, they were right. Yes, okay. 3 disjoint set means what? Lakshita? I just have 3 sets, okay? Okay, this is P, this is Q, and this is R. These are three disjoint sets. Okay, they have nothing in common. Now let us take the first sum. Out of a group of 20 teachers in a school, 10 teach mathematics, 9 teach physics, and 7 teach chemistry. 4 teach mathematics and physics, but none teach both mathematics and chemistry. How many teachers teach physics and chemistry? Okay. So total number of teachers is 20. So M union P union C, mathematics union, physics union, chemistry is 20. Now what do I have is N of M. So physics, how many, math, how many are teaching? 10. Physics, how many are teaching? 9. Chemistry, how many are teaching? 7. How many are teaching maths and physics? So M intersection P is how much? 4. How many are teaching maths and chemistry? 0. Okay, there are no teachers who are teaching there. So how many? They are asking how many teach only physics? How many teach chemistry and physics? And only. So what this means is, how will it look like in the diagram? I have maths, I have physics, and I have chemistry. Okay, this is my maths, this is my physics, and this is my chemistry. Why I have not done a diagram like this? Because I don't have common. I don't have anybody who is teaching maths, also physics, also chemistry. So my diagram changes like this. Now, what is the total for maths? 10. Okay, 10 teach maths. How many teach physics? 9. And how many teach chemistry? 7. Okay. How many teach both maths and physics? Maths and physics you have 4. So how many teach only mathematics? There are total 10 mathematics teachers. Out of those 10, only 4 are there who teach maths as well as physics. So how many teach only mathematics? Okay, how many teach only mathematics? Okay. They have not asked in the question, but I'm just giving you this as an additional answer. Only mathematics is equal to 10 minus 4, which is equal to 6. So there are 6 only mathematics. Now physics and chemistry, I don't know which are the common ones. Okay, I don't know how many physics teachers are there who teach chemistry also. Okay, so for that I will use the formula. Okay, for that I will use the formula. Which is the formula? I will use it for, okay, N of M union P union C is equal to N of M plus N of P plus N of C minus N of M union P intersection. Minus N of M intersection C minus N of P intersection C plus N of M intersection P intersection C. Now, do I have any intersection common? Anybody is there who teaches maths as well as physics as well as chemistry? No. So this is 0. Okay. So what is this? 20 is equal to M union P union C is given to me as 20. N of M is how much? 10. N of P is how much? 9. Then you have 7 minus M intersection P. How many teachers are there who teach maths as well as physics? There are 4. Then maths with chemistry, 0, because there is no teacher who teaches maths and chemistry. So this is 0. Then maths, physics and chemistry, I don't know, X. And how much is this? Maths and chemistry and physics, that is again 0. So this is 20 is equal to, how much is this? 10 plus 9 plus 7 minus 4. So 22. 22 minus X. Or X, which is equal to number of teachers N is number of teachers who teach physics and chemistry is equal to 2, because 22 minus 20 is equal to 2. So here I will write down the value 2. Okay, here I will write down the value 2. So out of 9 physics teachers, what does this mean? Out of 9 physics teachers, 4 teachers are there who can teach maths as well as physics, and 2 teachers are there who can teach physics as well as chemistry. So how many teachers are there who teach only physics? How much would this be? Only physics will be equal to 9 minus 4 minus 2, which is equal to 3. Okay. Only physics, this is equal to 3. Okay. How many teach only physics? Answer is 3. Okay. What I have done, I have first taken all the information, written it down. Second, I drew the Venn diagram for my understanding. It is for you. Okay. If you don't feel you need to draw, don't draw. Okay. Only thing you are required to do is then use the formula, find out the teachers who teach physics as well as chemistry. So now amongst all the physics teachers, there are physics teachers who take both maths and physics. There are some teachers who take maths, who take physics and chemistry. And then there are some teachers who take only physics. So that is what they have asked us to find out. How many teach only? The word only is very important. Only physics. That is, out of all the physics teachers, I will first remove the teachers who teach physics and chemistry. I will remove the teachers who teach physics and maths. So what I am left with are the teachers who teach only physics. And so answer is 3. Okay. So how many teach physics and chemistry? Answer is 2. Okay. For this, the answer is 2. And for this, the answer is 3. Okay. Clear? Yes. Let me know whether you've understood the sum. Okay. Next sum is 74% of Indians like grapes, whereas 68% like bananas. Okay. So how many Indians are there? Okay. When I have a percentage problem, I will take this to be Indians are 100. Then out of 100, number of grapes is 74. Number of people who like bananas is 68. Okay. So this is my grapes and this is my bananas. Okay. What percentage of Indians like both grapes and bananas? Okay. So this is 74. This is 68. They are asking us to find this. Okay. They are asking how many Indians are there who like grapes as well as bananas. Okay. So what is the formula? N of A union B is equal to N of A plus N of B minus N of A intersection B. Okay. See, in these sums, you only have to understand what they are asking you to find out. Okay. So this means what? N of grapes union bananas is equal to N of grapes plus N of bananas minus N of grapes intersection bananas. That is those number of people who like grapes as well as bananas. How much is N G union B? How many people are there? 100. Okay. Grapes and bananas total is 100. How much is grapes? Grapes is 74. How many bananas? 68. And G intersection B. This is what I am asked to find out. How many people are there who like grapes as well as bananas? So N of grapes and bananas is equal to 74 plus 68 minus 100. So how much is this? 74 plus 68, 142 minus 100, so which is equal to 42. Okay, so 42% will be the answer. Understood? Yes. Next sum. Yes, Rohini, good. Simon, let us do the next sum. You will, your understanding is going to increase. Very nice, Divya. Shalini, Anchal, Achal, Lakshita, Harshita, Zeba. Yeah. Okay. Yeah. Let us take the next sum so it becomes clearer. In a class of 60 students, 40 students like maths, 36 like science, and 24 like both the subjects. Okay. So I have here, this is my maths. This is my science. So this is my maths. This is my science. So there are 40 students who like maths. There are 36 who like science, and there are 24 who like both. Okay, 24 like both. So I must know where to put this figure. So 24 like both. So now this is 40 like maths, 36 like science. So how much is this? This is 40 minus 24. This is equal to 16 students. What does this mean? 16 students like only maths. Okay. And what is this? Okay. What is this? This is 36 minus 24, which is equal to 12. So I write this 12. Students like only science. Okay. They have given me that in a class of 60 students, 40 students like mathematics, 36 like science, so and 24 like both. So 40, in those 40 students, there are 16 students who like only mathematics, and 24 students are there who like both mathematics and science. Out of the 36 students who like science, there are 12 students who like only science, and there are 24 students who like both maths and science. Okay. Now I can see that what is the total number of students? 60. So how many students? So total students is equal to 60. So students who like maths, science, or both. How many students are there who like math, science or both? So this is 16 plus 24 plus 12. How much is 16 plus 24 plus 12? 16 plus 24 plus 12, 52. Okay. So there are students who like maths, science. So number of students who don't like maths or science will be how much? 60 minus 52. That is, there will be 8 students in the class who don't like maths also and who don't like science also. So first they are asking is, so once I have drawn this, I can answer this very easily. First is, how many students who like maths only? So what is the answer? 16, right? Because here I can see, okay, this red area consists of students who like maths only. So 16. Science only. How much is this? This. So this is here. Science only. How many students are there? 12. Either maths or science. So either maths or science is how many? 52. Okay. This is either maths or science. This is 52. Neither maths nor science is equal to 8. Okay, so important thing here is that you draw the Venn diagram, mark all what is given to you, and then based on that make the calculations. Okay. Right? Yes. Yes, Lakshita. Yes. Yes, Harshita. Yes. Very good. Okay. So now let us take example in set 7a. First question is, the number of subsets of the set 2, 3, 5 is. So what is the formula? Number of subsets is given by 2 raised to n, where n is the cardinal number. So I have n is equal to 3 here. Therefore, number of subsets is equal to 2 raised to 3, which is equal to 8. So answer is B. Okay, answer is B. Second, the number of subsets of a set containing n elements is. Okay, they have directly asked you the formula here. So number of subsets of a set containing n elements is given by this 2 raised to n. So this will be the correct answer. The null set is represented by, okay, the null set is represented by, this is not the correct one, this is not the correct one, this is the correct one. This is the correct representation of the null set. Okay. Now A is given, B is given, find out A intersection B. A intersection B means what? Elements of A which are also present in B. Okay. So here is 2 present? No. 3 present? No. 5 present? No. 7 present? No. So are there any elements of A which are also present in B? No. So this is what? Now, see, they will purposely do this to confuse you. So A intersection B is a null set. This is not a null set. This is a null set. Okay, so fourth answer will be A. Okay. So because A and B are disjoint set, so I can say that A intersection B will be a null set. The set X is such that X is from 0 to 5. Again here, see, this is 0 less than X less than 5. So I will not take 0, I will not take 5. So what will be the elements of the set? This will be 1, 2, 3 and 4. Because this is only less than, this is not less than and equal to. So 1, 2, 3, 4. So which of this? B will be the correct answer. Okay, 1, 2, 3, 4. So in case of sets, you simply solve it yourself and then look at the options. That will be a better option for you. Now the set 0, 2, 4, 6, 8, 10, it can be written as. So you can see these are all multiples of 2. So we will write it as 2x. And x should be such that because 0 is also there and 10 is also there. So x is such that 0 less than or equal to x less than or equal to 5. These two less than or equal to is important. So here C will be the correct answer. So 2x is such that x is greater than 0 but less than 5. Greater than or equal to 0 and less than or equal to 5. Okay. Now in this sum, data is given to you and you are asked to find out so set P is given, set Q is given and the universal set is given. So here you will be asked to find the questions on it. So I will just write this. P is 1, 2, 3, 5, 7. Okay. So the questions is P is 1, 2, 3, 5, 7 and Q is given 1, 3, 6, 10, 15. Universal set is given from 1 to 15. You are asked to find the cardinal number of P intersection Q. So P intersection Q. What is P intersection Q? Common elements in P and Q. So 1 is there, 3 is there. Okay, 1 and 3. No other common element? 1, 3. Yes. So cardinal number is B is equal to seventh answer, that is B option, that is 2. Okay. Now they are asking you to find out P union Q and then find its cardinal number. So P union Q. P union Q means take all the elements of P and take all the elements of Q and write them down. So P is how much? This is 1, 2, 3, 5, 6, 7, 10, 15. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is the answer for the 8th sum? What is the cardinal number? 8. Because there are 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now they are asking you to find out P dash and then find its cardinal number. Okay. So P dash. How much is P dash? All the elements of P which are not present in S. So let us see all the elements in S which are not present in P. 1, 3, 5 and 7. So what will this be? 2, 4, 6, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or something is missing. We want P dash, no? So 1, 2 is also not there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So A is the correct option. Okay. Next question, they're asking you to find out Q dash. So let us see Q dash. What is Q dash? 1, 3, 6, 10, 15. So what is Q dash? 2, 4, 5, 7, 8, 9, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So answer here will be n of Q dash will be 10. Okay. Now let us go to some theory questions also in sets. Now 1 minus 1 raised to x for all integral x values is. Okay. So what does this mean is that start putting the values of x. Okay. Start putting the values of x as an integral value. So I will put x as 1, 2, 3, 4. So let us see what happens. So if I put x as 1, what will I get? 1 minus 1 raised to 1. So minus 1 raised to 1 will be, this is minus 1. So 1 minus of minus, that is plus 1. So this is 2. What if I put x as 2? Okay, this is 1 value. Then 1 minus of 1 raised to 2. Minus 1 square is what? Plus 1. 1 minus 1, answer is 0. Okay. Let me put x is equal to 3. So 1 minus 1 raised to 3. Minus 1 raised to 3 is minus 1. So this is 1 plus 1. Answer is 2. Let me put x as 4. 1 minus 1 raised to 4. Minus 1 raised to 4 is plus 1. So 1 minus plus 1. So answer is 0. Okay. So you can see that you are getting either 0 or you are getting 2. Okay. You are getting 2 or 0. Here also you are getting 0, 2. So C is the correct answer here. Okay. Now E is a set of positive even numbers and O is a set of positive odd numbers. Then E union O is a set of whole numbers, a set of natural numbers, set of rational numbers. Now what happens is that E is a set of even numbers and O is a set of positive odd numbers. So E is also positive even numbers. O is a set of positive odd numbers. So when you find their union, so what will happen? You will have positive even numbers and positive odd numbers all coming together. Answer is N. Okay. So union of E union O will be the set of natural numbers. What is N? N is a set of natural numbers. Now R. R is a set of positive rational numbers. E is a set of real numbers. Okay. So what does E contain? E will contain positive rational numbers, negative rational numbers, positive irrational numbers, and negative irrational numbers. Okay. And what is R? R is only positive rational numbers. So it is just one part of the whole E. So we say that R is a proper subset of E. Because this is also true. R is a subset of E. But B is a better answer because R is a proper subset of E. Now N is 16th is N is a natural set of natural numbers and I is a set of positive integers. Then N is equal to I and N is a subset of I. N is a proper subset or N is a subset of I. What will that be? N is a set of natural numbers and I is a set of positive integers. So what will be the answer? That they are equal. Okay. I is a set of isosceles triangles and E is a set of equilateral triangles. So you know what is equilateral triangle mean? Equilateral triangle means all the sides are same. So equilateral triangle is a special case of isosceles triangle. Equilateral triangle is a special case of isosceles triangle. So E is a subset of I. E is a subset of I. and it is a proper subset. Okay. So we will do the remaining sum in the next lectures. We have one more lecture with you. I have one more lecture with you for this topic of set relations and functions. So I hope till now you've understood this. Yes, very good that you've clearly understood. Very nice. Yes, Shivam, yes. Okay. Excellent that you are with me and you are able to understand all the sum. So thank you for your patient hearing. Have a great day ahead and we will take up the remaining of the question next time. Okay. Thank you. Tech support.